In this video, we're going to learn what we need to calculate a quantity called the equilibrium constant, KEQ for short, and we're also going to then learn a little bit about what the KEQ, or the equilibrium constant, will do for us, what it'll tell us in a reaction. So if we had some reaction, I call it a generic reaction because there's no actual substances here. So if A is reacting with B in a reversible reaction to produce C and D, and we allow it to go to equilibrium, and when we balance this equation, then the lowercase letters are the balancing coefficients, so maybe 1 and 2 and 2 and 1, whatever these happen to be. These are just the balancing coefficients, so we have A moles of substance A and B moles of substance B, etc. Okay? Then this equilibrium constant, or KEQ, or sometimes just K, is defined as this equation right here. KEQ is the concentration, and the square brackets, we've used those before, they mean the concentration of C, but that's raised to the lowercase c power, that's what goes here, and then D, in brackets again, raised to the D power, all over the same thing for A and B. And again, the square brackets mean equilibrium concentration in moles per liter. So we can put numbers in there without units because the brackets themselves are the units. But the important thing to remember here is that we raise these to the power of the letter that's out in front, or the number that's out in front of each one of these. So sometimes that's 1 and sometimes it's not. But you got to be careful to leave that in there, and that is an exponent, so you are going to take this value that's inside the brackets and raise it to that exponent. All right, now where did this come from? Well, it's derived from reaction kinetics, which is the rate of reactions. And if we write some equations for that, and we do not do that in this course, we write the equations for the forward and reverse reactions, the actual mathematical equations to calculate the rate, we can come up with KEQ. And somebody decided that we would put the products on the top of this and the reactants on the bottom. So KEQ is essentially the value of the product's concentration over the reactants. Okay, now, again, it's actually concentration of the things that are on the product side over the concentration of the things that are on the reactant side. All right, so if this is what KEQ means, then let's consider what does it mean if KEQ is large, small, and around 1. So I'm going to pause here for a second, and you push the pause button, and you think about it and write down what you think it means if KEQ is large, small, or around 1. Okay, so if KEQ is large, if this number here is large, it means this fraction is big. This fraction would be big if the things on top are bigger than the things on the bottom, greater than 1 maybe. So we would say that there were a lot of products produced, or we would say the equilibrium occurs after a lot of products are produced. There would be very little reactant then, very little reactant. If KEQ is small, then this number is small, which means this is a fraction with a small number on top, a big number on the bottom, a lot of reactants left, not much product, so the equilibrium would be reached quickly while there was still a lot of reactant left to react and not much product produced. And if it's around 1, then these would be about the same, so the equilibrium will be reached when the amount of product and reactant are relatively close to each other. Okay, so that's what KEQ will do for us. It'll tell us when a reaction, a reversible reaction, that's what I'm trying to say, will reach equilibrium. Now, one thing about this I haven't mentioned is equilibrium constant does depend on what the reactants are, but it also depends on the temperature. So we will assume throughout this that the temperature doesn't change. All right. On the remaining part, we will look at doing some calculations.